Hey guys, let's do something a little bit different. We're going to talk about a piece of test equipment and review some test leads. A while ago, sometime last year, I picked up a bunch of stuff from a seller. I think he was in Indiana. Got a couple TVs, a cool Simpson tube tester, a bunch of tubes, and some radios, and in the mix of all that stuff was this guy, which is a Simpson multimeter. I never saw one quite like it before, didn't know much about it. Popped the battery in, didn't turn on, just put it on the back burner. But now and then I would poke around with it, just curious why it wouldn't turn on. Difficult to work on, strange construction. But a few weeks ago I finally figured it out. It turned out to be something really weird. It uses a 9-volt battery. Where the 9-volt battery connector goes and connects to the circuit board, somebody cut both traces. And it looked like the soldering had been reworked. What I think they did is they rigged it up so it could run off an external power supply and just killed the internal battery connection. I just bridged those broken traces and voila, it seems to work. However, I didn't have any probes for it. And these are unusual probes. Unlike these guys and this Fluke, which are banana jacks, these are reverse banana jacks. I've been come to find they're called. In other words, these have male connectors buried down inside here. There are male banana jack ends sticking out towards us. This thing is a little crusty. Let's see if we can find an age. This particular one apparently was branded for Xerox, so it has a Xerox model number on the manual, but on the inside cover it says it's identical to a Simpson 467. Let's see if we can find effective date 4/8/2. Maybe that means 1982? Yeah, I mean, it seems about right. 80s, early 90s, something like that. Came with this little cheat sheet too. Simpson Electric Company, Elgin, Illinois. Now, particular, what I find curious about this is the alleged history of it. There's a reason why I have this Fluke 27 next to it, which I use all the time. Supposedly, allegedly, both of these designs were competing for a government contract, and the Fluke 27 won out. Both of these are pretty darn common, but this 27 is especially common. I have 3 of them now. I've got them all for about 20 bucks a pop off of eBay, because they show up in government auctions on a regular basis, and usually a seller will have sometimes dozens of them for sale at the same time. Great meter. I'm sure you've seen others using them, Shango and many others. We all, I think, use them for the same reason. They're cheap, and they're built like tanks, and they have all the full specs of whatever cat they're rated for. If it says it's good for 1,000 volts, you can trust it, or 10 amps, you can trust it. They're fused. They're really dependable. But yeah, they are old. They don't have any modern features, no USB connection, no Wi-Fi, not even a backlight on the LCD. Well, this has all the same features, but built in a completely different manner. The Fluke uses a custom Fluke chip, and is a conventional design, handheld with the rotary control in the middle, whereas this is a little workbench type design with a kickstand kind of thing on it. And inside it uses all off-the-shelf parts. The classic Intersil 7106 dual slope 3.5 digit A/D converter. Uses a off-the-shelf Analog Devices true RMS converter. I think it's the 536, and so on. So totally custom design, totally off-the-shelf design, and this has little push buttons and switches. Oh yeah, I didn't realize the Fluke is auto-ranging. This is not. But it's kind of cute. It's small, and it seems to work. Now, something else the Fluke has, that both of these have, is there's a bar chart on the bottom. It sort of simulates how an analog meter would be. So So you want to peak the IF response. Rather than watching numbers fly by and updating slowly, the bar actually moves back and forth, kind of like an analog meter. This does the same thing, but with a separate gigantic chip they put in there. Here is the full schematic for it. There's a lot going on. The Fluke has like one chip in it, and that's it. This has a dozen integrated circuits. So this guy, the MD, what was it, 4332? This chip is just for the bar chart. It's that's a crazy thing. So all these outputs, each one of them just drives one segment of the bar. And there's the 7106 on the top. And there's the AD, sorry, it's a 636. In the middle of our screen there, that's the true RMS converter. Then there's a whole bunch of other chips to do, like it has a peak hold feature, it does beep for continuity checking, diode check. They did it all with discrete parts. What a crazy, crazy thing. But it's cool because, well, aside from it being really small and cramped, you can fix it. You can get all these parts. It might be a little tricky to get some of them, but they were all commercially available parts. Alright, so I didn't have probes for it. I found a place that sells them. The original Simpson probes could run you a good $100 if you can find them. But Probe Master, I found out about them from researching on the Antique Radio Forum for somebody trying to find probes for this, and somebody recommended them. Made in America, I'm not familiar with them, but boy, they sure have a wide variety of probes on their website with a lot of options like lead length. You get 2 foot, 3 foot, 4 foot, 5 foot, 6 foot. Hey, look at that. I got a copy of the Constitution. Alrighty. I can edumacate myself. What a neat thing. They weren't that expensive. $34.90 plus $5.50 shipping, so $40.40 for some good old made in America probes. And this is not just a probe, this is a whole probe kit, where we have by default the very sharp, looks like they're gold plated tips. We've got screw-on, little clips for integrated circuits, alligator clips for beefier stuff. Cool, cool. Now these leads that are on my Fluke right now are kind of the opposite. These I bought by mistake. I thought they'd be compatible with the Simpson, but they are not. These were $10. These are made in China. These are kind of flimsy. I do not trust when they say they're Cat 3. I would not try to put... I think Cat 3 means 1000 volts, 10 amps, something like that. I don't know about that. Those also came with screw-on alligator clip ends, I think. But they feel cheap. So, let's get these out. I like that they have little protective covers on these tips, which I suspect are very sharp. And you could easily draw some blood with them. Yes, those are very sharp. There's a Probe Master right on the body of these probes. Okay, I can already tell this is the real deal. This is the kind of, they use special wire for test leads. Usually just a single thin piece of copper, so you get maximum flexibility with least amount of resistance or something like that. I forget exactly what the theory is. And these are probably silicone. They're very flexible, very smooth. These might be, they don't feel as good. It's not as flexible. Let's see, yes, so yeah, these have the female end on the probe ends versus these guys. So this is the more conventional, this is the version we need for the Simpson, so I can finally actually use this. Separate jacks for current versus volt ohms. Let's do the volt ohms first so we can just test some resistors. Yep, seem to work just fine. And let's see. Let's go into the resistance mode. Yeah, maxes out because we have infinite resistance right now. And there we go. 0.0. Let's try. Yeah, they show a musical note when these both depress, so I think this is your continuity check. Yep. Cool. Let's grab some resistors and give it a try. Probe Masters. Since 1980. I don't know how I managed to never hear about these guys. Yeah, everything is gold plated. Very cool. Alright, I grabbed some resistors from across the spectrum, everything from less than 10 ohms to more than 10 or more than 5 mega ohms. So let's see how we can do on the various ranges. I'll switch to one of these adapters here. So I can clip the resistor on. Let's see what all we got here. Oh, we got some heavy lugs for doing current measurement, I imagine. I could see those handling 10 amps pretty easily. We have a couple nicer safety tip covers for those pointy ends. We have the alligator clips. Everything's gold plated. These have very nice action on them. And we have these guys. Seem very nice. I'll go with the alligator clip variety. Looks like these just screw on the end. What do we got? Just a 12. Let me get a precision one if I have any handy. 10K, this might be precision, I'm not sure. Well, that better be a 5K resistor or something's not right. Oh yes, it is a 5K resistor. Okay, I misread it. Alright, 5.05. What do we got? 8.2. 8.1516. Alright. Now I do have precision resistors for the mega ohm range, so let's jump to one of those. There's a 4.7 meg resistor. I think these are 1%. That's having a little trouble. I wonder if that's because it's actually attached to this tape. It might have some conductance. Oh yeah, I guess it does. 4.64. Never occurred to me that this. So when you buy resistors in bulk, they often come on these tape reels that they're for machines that place parts, kind of like an ammo belt. I didn't realize that there's actually, when you're talking mega ohms, these actually have some continuity to them. It throws the reading off. Let's try another one for the heck of it. I think this is 5.1 meg, 1%. That's within 1%. Oh, I can compare it to the Fluke too. Neither one of these has been calibrated. I don't even know if they have calibration capabilities inside. Yeah, 5.11. And let's try a small value. Just a 3.3 ohm resistor. Well, that doesn't seem right. I wonder if my battery's maybe not fresh enough. It's not liking this at all. Let's try it with the fluke. 3.3, 3.4 on the fluke. Alright, so either there's something up with this on the lowest range, or my 9-volt battery maybe is not that fresh, because I believe it draws more current when you're checking a very small resistance value. Alright. Now, as far as which one would I use, I think I'd stick with the fluke for auto ranging, if for no other reason. It also has a larger readout. This has a kickstand on it too. You want to have it upright, and neither one's backlit. Honestly, the only reason I have this is because it came with all the other stuff I bought. But it is a neat little thing, for sure. I'm not going to go through the rest of the functions. It's a multimeter. It can do voltage. It can do current. True RMS, what does that mean? It means if you put in a complex waveform, it can figure out what the real mean square equivalent voltage is. It doesn't assume it's a sine wave that can handle a complex waveform. That's what true RMS means. And the Fluke 27 is also true RMS. If I do use it, it'll be in a semi-permanent application, like maybe to monitor the output or current draw on a variable power supply on my bench, something like that. Mostly I wanted to check out the probes. This is not a paid endorsement, by the way. They didn't send me a sample or anything. I just stumbled across them online. But they do also have scope probes and BNC cables, and I need both. In particular, BNC interconnects, because I've been teasing you guys with making my own TV transmitter setup for a long time. I finally got myself some rack rails. So I'm going to be busting this out soon and finally assembling all those bits and pieces I've been teasing you guys with for the last couple of years. And see if we'd actually broadcast some test patterns and some video material. That'll be coming up in a separate video. That's going to be it for now. Thanks for watching.